Hello everyone and welcome once again. This is Lecture 2 and I'm Dr. Jim Marion, your instructor for MBA6961, Project Management. We've got a lot to discuss today, a lot of interesting material that will help you be better managers and better project managers. So here we are again, Lecture 2, and a picture of me at my best. So let's continue. Here are the many things I want to discuss today. First of all, a memory challenge. Some students have asked me in the past, why didn't you make me memorize the PMBOK framework? That would have been an enormous help to me in passing the project management professional exam. Okay, so that's a reasonable point. My personal point of view is maybe memorizing it isn't necessary, but almost completely memorizing it is easier to do than you might think. I think memorizing 90% is easier than memorizing 100%, but maybe that's all you need. So I'm going to show you how that's done in today's memory challenge. Also, we're going to investigate in more detail some selection tools I mentioned in the last lecture, and we will also look at more detail at scope. Scope is very important, and some elements of scope and scope development and scope management may be a little bit different than you might expect. So we'll discuss those. We'll follow up with estimating. And then we will discuss alternative scheduling methods. You primarily learn one way to create a schedule in the project management body of knowledge, but there are a couple of other ways that it can be done. Some companies use them, so you should be aware of what they are. All right, so let's begin with our memory challenge. This is memorize the PMBOK, and BOK is body of knowledge. It's for project management body of knowledge. I'm specifically referring to the framework. And again, at the end of this, I don't think you'll need to memorize 100% of it, and I'm not going to show you how to do 100% of it, but I'll get you close. Now, so passing the exam is one reason to be able to do this. Another, imagine yourself in a room full of people and you're in front of a whiteboard and you're coming in and you're explaining to this group of people how to manage a project. Wouldn't it be nice if you could write at least most of the guide to the project management body of knowledge on the whiteboard and explain it to them? It's a very powerful ability if you can do this. So and you get a lot of credibility and buy-in from your team. So let me show you how you might approach this. Okay, so let me just ask, do you think it's a good idea? I think so. Do you think it's possible without much difficulty? You probably don't think so. But let's just wait and see and give this a chance. All right. First of all, every one of you should know the 5 process groups: initiating, planning, executing, monitoring and controlling, and closing. Anyone should be able to remember this. And think of it in terms of common sense. Okay, if you think of initiating, planning, executing, monitoring and controlling, and closing, and just common sense English, you may think, okay, initiating, that's like starting. Planning is thinking about what you're going to do. Executing, that's actually doing it. Monitoring and controlling is making sure you stay on top of things and you don't lose track of what's going on. And then closing is finishing it. So initiate, plan, execute, monitor, control, and close. You can think of start it, think about it, do it, stay on top of it, finish it. That's common sense. So just common sense alone should help you understand the 5 process groups. Also, you can think of another abbreviation for this. And let me show you. Notice the first letter. IPE, you have monitoring and controlling. And it could be abbreviated as controlling, followed by closing. So you could think IPECC. So to memorize the 5 process groups, you're almost there. Initiate, plan, execute, monitor and control, or close. Or IPECC. Or start it, think about it, do it, stay on top of it, finish it. That's easy enough, right? Okay, now the tough part, and I know you might be thinking this, the tough part is going to be the knowledge areas. Okay, fair point. So let's take a look at the knowledge areas. There's 10 knowledge areas in addition to the 5 process groups. Integration, scope, time, cost, quality, human resources, communication, risk, procurement, and stakeholder. That's a lot to remember. Well, and this is how I remember it today. I don't remember it using all 10 words. I remember it thinking of that one sentence. I saw the customer quote his common requirements plan systematically. Let me show you this again. I saw the customer quote his common requirements plan systematically. ISTCQHCRPS. I saw the customer quote his common requirements plan. So instead of remembering 47 things, you have to remember 6 things. The 5 process groups plus 1 sentence. So let's see how this goes. The 5 process groups, okay, common sense, you have start it, think about it, do it, stay on top of it, finish it, or initiate, plan, execute, monitor and control, close, or IPECC. Now what about the 10 knowledge areas? Okay, I saw the customer quote his common requirements plan systematically. I, integration, saw the scope time, customer, cost, quote, quality, his or her, human resource, common, communication, requirements, risk, requirements, plan, procurement, plan, and systematically is stakeholders. So I saw the customer quote his common requirements plan systematically. You can remember integration, scope, time, cost, quality, HR, risk, communication, procurement, and stakeholder. There you go. And that's how I remember it, by that mnemonic device. So to remember the PMBOK framework, remember the 5 process groups, and remember this one sentence. And if you do that, then you know all 10 knowledge areas. So what happens next? Now you can put it in matrix form, where you have the 5 process groups on the top, and then the 10 knowledge areas on the side. As you can already see, you're getting close to having the PMBOK framework in place. But you have to do one more step. Each of these has to be populated. And remember, the project management body of knowledge is very systematic. In each case, you plan something, you do something, you close something. You're almost there. So what do you do to fill in the blank? Well, let's look at a simplified view of the project management body of knowledge. I've got keywords here. And I want you to notice something very interesting. Planning is the #1 process group in terms of processes supported by the PMBOK. Almost everything done in project management, it requires you to plan first before you do something. So naturally, you see almost all processes are in planning. The second largest one is monitoring and controlling. So this makes sense. What the PMBOK is saying to you as project managers is, we want you to plan out everything carefully and then control what you've planned. Make sure that your plans are being carried out. So that's where most of the work is in memorizing the PMBOK framework, in planning and in monitoring and controlling. All right, initiating is very little. There's only 2 things: integration, which is your project charter, develop charter, and stakeholder, identifying stakeholders. So there's only 2 things in initiating and 2 things in closing. Most of the work in memorizing this is in planning, followed by monitoring and controlling. And what are you doing in monitoring and controlling? You're doing nothing more than controlling what you planned. And executing is directing and managing, performing QA, acquiring your team and managing your team. So by using these keywords, I think you can come close to memorizing enough of what you need to memorize to get close to the real thing. And what's the real thing? It goes a little bit further, but this is the actual PMBOK framework. There's a little bit more detail here, but it's not too far removed from this abbreviated form, which comes from your populating of the matrix using the 10 knowledge areas and 5 process groups by remembering 1 sentence plus 5 things. So you need only remember, you only have to remember 6 things: the 5 process groups and the 1 sentence. I saw the customer quote his common requirements plan systematically. Once you have that in place, remember that initiating only has 2 things: developing your project charter, identifying stakeholders. Closing has only 2 things: closing procurements and closing the overall project. Most of the project framework is in planning and in monitoring and controlling. If you think about all the things you need to plan, you could spell that out. in the planning section, knowledge area by knowledge area. What do you monitor or control? You control only those things that you planned. And execution is really all about acquiring and managing your team, managing quality. It's very simple. So I think you got the basic idea. If you follow that, that framework will stick in your mind, and it'll be easier to remember. Okay, now I'd like to jump back again and discuss project selection tools, quantitative tools, in a little bit more detail. We mentioned this last lecture, but I want to make sure you've got the basic principle. I want to discuss the NPV and the IRR. So let's take a look. That's the net present value and the IRR. Remember, I told you that the net present value really asks you to compare. You compare your project investment with the return of your project compared to what you would get in a secure investment, such as putting your money in the bank. And as you recall, positive is good, 0 is questionable, and negative is bad. Whereas the IRR is the effective rate, the internal return rate, is the effective rate that your project will receive. So I want to make sure you understand time value of money, because it's essential in project selection techniques. So $100 in your pocket today will be worth more tomorrow if you put it in the bank. If you just assume 5% interest, 1 year from now, $100 would be $105. That's 100 times 1.05. Now, if you ask this in reverse, what if you didn't have $100 today, but someone promised you $100 a year from now? How much is 100 promised in 1 year actually effectively worth today? If we assume the 5% interest, you just reverse the equation you just did. Instead of 100 times 1.05, it's 100 divided by 1.05. So if you set it another way, if you put 95.24 in the bank today earning 5%, in 1 year it would equal 100. So $100 promised 1 year from now, and here's an important term, $100 promised to you 1 year from now, assuming a 5% interest rate or discount rate as it's referred, you effectively discount that $100 to the present. And discounting $100 to the present, assuming a 5% interest rate, gives you $95.24. That's the present value of $100 1 year from now. But you might ask, what about more than 1 year? Well, 1 year we know is 100 times 1.05. 2 years is 100 times 1.05 times 1.05. If you look at this carefully, you see that after 1 year you've earned $105, but then you're saving $105 for the next year. And so you earn interest on your original principal plus the interest it accrued. So in 2 years it's 110, 3 years 115. So the money in your pocket today multiplied by the discount rate raised to the power of number of periods. You could simplify this. Notice 100 times 1.05, 100 times 1.05 times 1.05, which is effectively 1.05 to the second power, or 1.05 squared. 3 years is 100 times 1.05 to the third power. Okay, so that's 1.05 cubed. So it's money times the rate raised to the period n. Okay, now if you want to discount it to the present, you reverse that. So for example, what about $100 that's promised in 3 years? Assuming a 5% discount rate, you have 100 divided by 1.05 raised to the third power, or 1.05 cubed, and that equals to $86.38. So some things to think about in project selection. The longer you have to wait for the promised money, the less it is worth today. Okay, and that's because if you had it in your pocket today, it could be earning money. But if it's promised in the future, the further out, the less it's worth today. Also, the higher the discount rate, the less the money is effectively worth. And the higher the discount or hurdle rate, the more money your project will need to generate in order to compensate for this. So this is like saying more risk, more reward. The higher the discount rate, the more money you have to earn to overcome this. The longer you have to wait for your money, the less it's going to be worth today, effectively. Okay, so now let's look at some complicating factors. What if the future cash flow is risky? For example, your brother-in-law promises you $100 in 1 year. This is something that you have to think about in project selection. Generally speaking, the more risky the project, the higher the discount or hurdle rate you must use. In other words, the higher the risk, the more return that project needs to produce. And that's how you reflect risk, by raising the discount rate. On the other hand, this could make projects look less worthwhile. For example, if anyone presents to you a number of projects and says, we're not going to do this project because the return, the NPV doesn't look good, well, the first thing you should ask is, what discount rate did you use? Is the discount rate consistent with the level of risk you're taking? So if you choose a discount rate that's too high, chances are you may reject a project that you should accept. On the other hand, if you use a discount rate that's too low, you may accept a project that has a lot of risk that you normally would not accept. This is why low interest rates tend to grow business, because if the overall cost of money is low, it makes even risky projects seem worthwhile to take. Okay, so if you are factoring in more risk, you have to increase the discount rate. All right, and the interest rate, and also if you're going to have inflation in the future, you add that inflation rate to the discount rate. For example, if you have a 1% per year inflation rate, you add 1% to the 5% or whatever is your standard discount rate. Okay, so think in terms of more risk and more reward. All right, so let's look at some quick examples. Here's the formula. Starting off with present value. Before we talk about net present value, just look at present value. And we've already seen that. The future value divided by the discount rate raised to the power. We already saw, for example, the example of $100 in the future, discounted 3 years was equal to, the present value was $86. All right. Here's an example: $100 received, or $100,000 received 1 year from now at 10% would be worth $90,909 today, because you divide 100,000 by 1.1. If you invested 100,000 at a discount rate of 10%, it would be worth 110. Okay, so simple examples. Okay, the net present value. Let's take a look at an example of net present value. You have initial outlay plus income of the project for each period. Here it's year, but it's whatever period you're using. And you divide it by the discount rate raised to the power of the period. In year 1, it's 1.r to the 1 power, which you don't need to state. 1.r, which is the return rate to the second year, third year, etc. Now, let's give a practical example. Let's say you were choosing between two projects, Project A and Project B. Project A has a negative cash flow of $1,000, meaning you pay initially $1,000, and then over time the money starts coming in based upon your the project returns, or the income coming in from the project. Project B also has $1,000 going out. Now, by inspection, let me point out a couple of interesting things. Notice Project A has $500 coming in very quickly. So remember that principle: the longer you have to wait, the less that money is worth today. So we see 500 followed by 400 and then smaller amounts later. In Project B, you've got larger cash flows, but you have to wait longer for them. So just as a guess, I'm going to say that Project A is better than Project B, but let's take a look. Here's the calculation that was used. It's assumed a 10% discount rate. You take the cash flows, divide it by the discount rate for each period, and here we see the Project B that has $700 coming later. That's a lower NPV than the one that has $500 coming in sooner, which is 134 or 114. Now, practically speaking, both of these projects could be worthy of selection because they are greater than zero. This means that both of these projects earn more money than if you put your $1,000 at the bank in the bank or in a secure investment earning 10% per period. Okay, so both of them are good, but the NPV of project A, which gets 500 and 400 earlier, that's better because you have to wait less time for your money, therefore it's effectively worth more. Okay, so that is an example of the NPV. Okay, now recall last time we were together, I mentioned that the IRR is another project selection method. That is the rate, the effective rate of your project, and it's the rate that produces a zero NPV. Now, there are very complex formulas that are used to calculate the IRR. Some financial calculators do it. You could do it in Excel, but I'm going to show you a simple way to approximate the IRR that you can use using the same formula as the NPV. So in this example, I put in a spreadsheet exactly what we saw before. What you see here on the very first line is the project cash flows, the initial cash outlay and the cash flows. This is for project B that has $700 coming in year 1, 2, 3, in year 5. $700 coming in year 5, and the NPV was 114. So I'm going to guess the IRR by adjusting the discount rate. And you could see what I did in spreadsheet form. I had 1.1 to the first power, 1.1 to the second power, 1.1 to the third power, and so on. So I see this comes up with a positive number. If I want to get this close to zero, remember the higher the discount rate, the less your NPV is going to be. So I need to bump up the discount rate. So let's try this. I tried from 10 to 20%, and I ran the same calculations, 1.2, 1.2 to the second power, 1.2 to the third power, etc. Here I get a negative number. So this is a negative NPV. So I know right away that the IRR of this project, the effective return rate, is somewhere between 114 and 187, minus 187. So if it's somewhere in between, I'm going to try 15%. When I try a 15% rate, I get an NPV of minus 53.59, which tells me I'm getting close. So I adjust it one more time, and 13%, I get an NPV of $8.99, which is close to zero. So I'm guessing by taking the NPV formula that's very easy to enter into a spreadsheet, it's not very complicated, I can quickly determine that the effective return rate of this project is maybe about 12.5% to 13%, somewhere in that range. And I've done this by making some quick adjustments to the discount rate to see where the interest rate or the effective return, or the NPV approximates zero. So you can see, looking at these amounts here, 13% comes to $8.99. So it's getting very close at 13. So maybe it's between 13 and 15. So sorry, I'd said 12.5 to 13. It looks like maybe around 14%, 14 and 13, maybe 14.5 or 13.5, right in that range. It would approach a zero NPV. So the only reason I show you this is that's a simple way to calculate the IRR by using the same formulas you used for the NPV. And again, the formulas are simply this: taking your cash outflow, taking your discount rate, running your calculations. Then you play with your discount rate until you hit NPV of zero or very close to it, and that tells you the effective return rate of your project. Okay, so that was the very first step of review from last week, and that was looking at project selection methods. Now let's go to project scope. I want to discuss this in more detail because there's a critical element of scope that most project managers get wrong, and that is understanding the role of the work breakdown structure and how it's used in organizations. So I'll quickly review some simple points, and then we'll look at more detail at the work breakdown structure. It was one of the most important fundamentals of project scope that there is. Okay, remember that a project starts with a statement of work, especially if it's in a contractual situation. If you're responding to a contract, the contract may have a statement of work. If you don't have a contract, you may not have a statement of work, and instead you develop a simple scope statement. The scope statement says a few things about what it is your project is going to do, what's the criteria, in very simple terms, and this scope statement becomes part of the project charter. Okay, remember the project charter has some element of scope in it, but fundamentally the project charter is about authorizing your project to get work done. And the scope statement is very simple. To make an analogy in American government, we have the Constitution of the United States, which is very small, but then we have all the laws of the United States, which is very large. You could fill warehouses full of laws that you find in the U.S. There's so many of them. Likewise, in a project, you have a simple scope statement that's very small, and then you have the detailed elaboration of scope, which can be potentially very large. Okay, the first step in elaborating the scope, or meaning communicating it in more detail, is the work breakdown structure. So the work breakdown structure is I will call it a structured outline of the deliverables of your project. Notice the word deliverable-oriented, grouping of project elements. Okay, so this work breakdown structure is really about what your project can be expected to produce. Okay, partial work breakdown structure. This is from your text. You've got major, the top level at the very top, partial elements, and then further sub-elements. The idea is to identify clearly everything you are going to deliver. One advantage of the work breakdown structure, it allows you to assign deliverables to different parts of your organization. You take the work breakdown structure and you create a structured organizational chart called an OBS, or organizational breakdown structure, and this allows you to assign work. For example, here's your work breakdown structure at the top. At the left here is your organizational breakdown structure that has the departments. So you can take a deliverable, create a work package to produce that deliverable, and you have a nice administrative tool for assigning that work through the intersection of the work breakdown structure and the organizational breakdown structure. Okay, you can also assign budgets to each of the deliverables that you assign to each department. And you could clarify the responsibility of each element of the work breakdown structure. Here you have names, you have task codes, you have people assigned, etc. But before we talk about assigning work, and remember, the work you assign may be more than the deliverables of the work breakdown structure. It may also be activities. Let's make sure we thoroughly understand the work breakdown structure. I want to share with you a series of slides that I saw in a presentation a few years ago at the PMI Global Congress. Now, this presentation that I'm about to review with you is based on the practice standard for the work breakdown structure. So if you go to pmi.org, and if you're a member, you can download the guide to the project management body of knowledge. You can also download other documents for free, including practice standards. And there's one for the work breakdown structure that clarifies how you would use it. That's just one of many practice standards that are available. Okay, so let's take a look at the WBS. What's the primary purpose for creating the WBS? I'm asking this because I'll tell you that if I ask 10 project managers, 5 of them might get this wrong. The purpose of the work breakdown structure is to elaborate scope. Whenever you hear the term scope, think about the word what. What will I deliver? Not who, not how, not when, not why. It's strictly what. What will I deliver? So it's, remember, deliverable oriented. Okay, let's look at some characteristics of the work breakdown structure. What would we expect to find? Okay, characteristics of a WBS, this is what you would expect to find in a work breakdown structure. It's deliverables-based representation of project scope. Now, you'll hear the term progressive elaboration. This means you may need to do some things again and again and again to really break it down further, break it down further, break it down further into smaller and smaller pieces, small enough so you can actually execute it. Why do you create it? Because we want to understand what will be included. And it helps you to understand complex work. Remember last week we discussed Frederick Taylor in scientific management. His ideas were taking larger work and breaking it down into smaller pieces. That's what the work breakdown structure does. Breaks down work into smaller pieces that you can actually execute. Okay, here's an example that you'll find in the practice standard for the work breakdown structure, a bicycle. Some interesting things you will find in a work breakdown structure. These are all pieces of the bicycle that must be delivered, that your project must deliver. Notice these are all nouns, no verbs. They're all deliverables, not activities. So if you're applying for a job to be a project manager and someone says, give me an example of a work breakdown structure, you should have a structured outline of deliverables. You should not have this. This is a project schedule. It is not a WBS. A project schedule includes activities, and that's fine. That's what a schedule should include. You may ask, if a work breakdown structure has no activities, how can that be? I need to do things to produce them. That's correct, but those things that you do to produce deliverables appear in the project schedule, not the WBS. So this is not a WBS, but this is. These are deliverables. These are activities. I want you to be one of the project managers who know the difference. Okay? It's not activities. It's not milestones. There's no dependencies. There's no duration. No cost, no resources. That's part of your schedule and plan, not your work breakdown structure. Work breakdown structure is only deliverables. Okay, why do it this way? Because I know it can be confusing. This prevents you, or at least helps prevent you, to get lost in the details before understanding fully what you need to produce. So the Project Management Institute says, listen, activities are important. We know that. But first think about what you need to produce. Once you've done that, then think about who and how much and how long. Because if you don't do that, you may include activities in your project that don't need to be there. This makes sure that the only activities, the only durations, the only milestones in your project are those that relate to producing specific deliverables that are identified in the work breakdown structure. All right, so the scope statement is important part of the work breakdown structure. Okay, so the work breakdown structure, you start with the scope statement, and then you progressively think about how you take that scope statement and break it into smaller and smaller pieces. Okay, let's look at types of work breakdown structure deliverables. Now, for product or service, it's easy to imagine what you might produce for a product. But some types of project that produces processes could be more difficult to envision. That's understood. But keep in mind that even if you develop a process, think in terms of what you might deliver in producing that process. For example, process documentation is an example of something you might deliver. Okay, so when you create the work breakdown structure, you're using nouns, not verbs. You are using a hierarchy to explain the relationships, and those who actually produce deliverables ought to be involved in creating them. Okay, so let's look at some further examples of work breakdown structures. Here's a product WBS. This is a training course. Notice we only have deliverables: training materials, logistics, resources, advertising. Now, the PMI does include one section of the work breakdown structure devoted to only those management deliverables that must be produced. And that's usually on the very final portion of the work breakdown structure. Here you see training course level 2 and training course level 3. So 100% of what you deliver should be reflected in the work breakdown structure. I will also tell you that sometimes, you remember I mentioned earlier about the work package, which is a method for assigning work to elements of your organization. You will sometimes hear that the work package is the lowest level of the work breakdown structure. I will say something slightly different from that. What you find in a work package involves the lowest level of work in the work breakdown structure. This is what you actually assign. But an actual work package typically involves not only the deliverables, but who's assigned to produce them, the cost of producing them, the time frame, and those are elements that really go beyond the WBS itself. So the work that you find in the lowest level of the WBS becomes a part of the work package, but it's not correct to say that the lowest level of the WBS is the work package, because there's more that goes in a work package than just deliverables. All right, here's an example of a wedding planning service for work breakdown structure. You may be thinking, wait a minute, a wedding must have some activities in it, because what exactly would you deliver in a wedding? Well, let's take a look. Notice still this work breakdown structure has all the elements of a wedding communicated in the form of deliverables: the attire, the ceremony, the reception, the entertainment, the rehearsal dinner, etc. It's all deliverables. Now here's a process work breakdown structure. This is relocation of your workplace. Okay, so here you have current location, target site, relocation staff, transition plan. Again, they're all deliverables. Okay, now the question might become, how do I get from this to a project schedule? Well, that requires a transition from deliverables to actual activities. And how would you do that? Once you have your WBS completed, then you start layering the activities on top of that. So the work breakdown structure identifies all of the what you need to produce. Once you've done that, you start to think about, okay, what activities must I engage in order to produce these deliverables? Okay, so now we start saying, what do we need to do to produce it? What outcomes, etc. Now you start seeing activities being layered on top of the WBS. This is no longer the WBS, this is the project schedule. Okay, and this is what you end up scheduling in your project management software. This is what you add to your scheduling tool to show what you're going to do in order to produce these. So whenever you show something like this, that's a schedule, not a WBS. A WBS is only a structured outline of deliverables. It includes no activities, no durations, no milestones. That goes in the project schedule. Okay, now let's move on to the next topic, and that is estimating. All right, core concepts you'll see in the PMBOK are cost management, estimating costs, determining cost and budgets. This is not an easy thing to think about. There are many different approaches to estimating cost, and I will just tell you from my own experience, top managers tend to think of cost in terms of top down. Like, this is how much this project should cost. This is my department budget, and I want you to make this project fit into my budget. So you take this budget number and you break it into pieces and assign it to elements of work. That's a top-down budget. Often it comes from management. The project team, though, is working according to a different set of incentives. A project team wants to be assured that it has enough money to actually complete the project. It wants to be able to do everything it commits to doing, right? So the project team wants to look at every element of work in detail at the lowest level of the task and then think upwards. So the project team tends to focus on a bottom-up estimate, whereas the management tends to focus on top-down. Bottom-up tends to be a bigger number than top-down. And so often the two approaches don't quite meet, and so there's negotiations involved that typically happens. All right? So let's take a look at some of this. First, let's look at project costs. What do you need to think about when you're managing a project? You've got labor, materials, subcontractors, equipment and facilities, travel, many different elements of cost. You also have categories of costs, such as direct versus indirect. Recurring means one time only. For example, in projects I've been involved in, we often would pay something called NRE, non-recurring engineering fees, to pay for specific developments or a piece of software, for example. You've got fixed versus variable cost and normal versus expedited. Okay, so these are a number of different categories you need to think about in estimating cost. So first of all, think about what sources, like where do all these costs come from, and then the nature of the cost. Is it directly related to the project or is it indirect? Does it happen once or does it happen again? Is it fixed, a set amount, or does the amount vary according to what you do in the project? Normal versus expedited. Sometimes you're ordering a special component and it takes a long time, but you may have to pay fees to get that component sooner, which is an expedited cost. Okay, let's look at cost classifications. You had type, frequency, adjustment, and schedule. Direct labor, that's direct, it's recurring. Building lease is indirect, it's also recurring. Expediting cost is direct, it's non-recurring, it's variable. Material is direct and recurring and variable. So what's the message for project managers? Know where your costs come from, know the categories of cost, what you include, what you don't include. I know in my years as a project manager, I was responsible for the cost of the project plus the financial returns of my product once it delivered to market. However, there were other costs I wasn't responsible for. Overhead cost of the facility and the senior management team. That was the job of the general manager, not the project manager. But it varies from company to company, so you must be aware of what your company's policies and procedures are and what costs you have to deal with. Okay? Now when it comes to estimating your project, being aware, with awareness of all these costs in mind, there's different types of estimates, a ballpark or order of magnitude. And sometimes this is called a ROM, a rough order of magnitude budget. I'll just spell this out, ROM, rough order of magnitude. And notice that the ROM budget has a great variance to it. It's very inaccurate. Whereas if you compare to other projects, or you're doing a detailed feasibility, or you're doing a definitive estimate, you're going to get much closer. So students often ask me, if the rough order of magnitude estimate is so variable and is so inaccurate, why do it? That's an excellent question. First, let me start off by explaining that all estimates are wrong. If they were correct, they wouldn't be estimates. They would be actuals. Estimating means thinking about how much something will cost before you actually do it, right? So all estimates are going to be wrong by a certain amount. A rough order of magnitude estimate, when I say more order of magnitude, that refers to multiplying or raising something to the power of 10. So, examples of differences in orders of magnitude would be 10, 100, 1,000, 10,000, 100,000, a million. So, rough order of magnitude is intended to have a very high possible range. However, it does help you understand the scale of your project. It answers the question, is this a $10,000 project, or is this a $100,000 project, or is it a $1 million project? That's what rough order of magnitude helps you understand, and that information is important. There's another thing to consider. When you look at the differences between rough order of magnitude and definitive, notice that the more definitive your project estimate is, the more time and resources that must be spent in order to arrive at that definitive estimate. So if you want an estimate very quickly, and management always wants it quickly, if you want it quickly, it's going to be more incorrect. It's going to be more variable. If you want something definitive, it's going to take time and effort. So the problem is, if you have an estimate that is definitive, by the time you receive that estimate, it may be too late to act on it. So this also lends credence to using a rough order of magnitude estimate. You can have it very quickly, and you can understand the scale of what you're getting involved in. That and alone is enough to make an early management decision. Definitive estimates naturally come later, but if all estimates were definitive, in many cases your estimate would be completed. By the time it's completed, it's too late to make a good management decision. So this is why rough order of magnitude estimates can be very useful. Another element to consider in project estimating is the learning curve. Now, you'll see this in your text, and you'll see a lot of discussion about this. And the learning curve is based upon volume manufacturing and a high degree of repetition. And there's this mathematical formula that's associated with it. The time required for a certain unit of output, time required for initial unit of output, the slope of the learning curve, etc. Let me give you my professional opinion on this. The learning curve as a principle is useful. The learning curve with respect to the formula given in the text is not so useful. And the reason is what's given in the text assumes a high degree of repetition, a very long period of time that's more consistent with an ongoing operation such as manufacturing and is not typical of a project situation. So this learning curve formula, in my view, rarely applies to a project. However, the principle does apply. If you have done something once, the next time you do it, you'll have some experience and it should take less time. How much less time? Well, that's difficult to say. It depends on how much of the work you're doing is completely new, how much you're familiar with, how long your team has worked together. There are a lot of complexities there. You will rarely see a formula this elegant being able to be calculated for a project, even though the book shares it with you. And the reason is there is no long run in a project. Remember, a project is unique. It has a beginning and an end. It's a short run activity, not a long run activity, so it's very difficult to apply something like this. But do remember the principle. If you've done it once, the next time you do it, your estimates could assume that you'll be more efficient at it. In software development, there's a type of analysis called function point. I don't know if any of you have heard of function points. But function points are one of many attempts at trying to arrive at accurate estimates for software development. And the reason is software is invisible. It has an infinite number of working parts. It relies heavily on good teamwork, good communication. It's very difficult. So this is why you think of a lot of intangibles when you're doing software development estimates. Okay, this is an example of development time and the number of lines of code. You know, for example, when I worked at Panasonic, we did lines of code estimate. There's other types of estimation methods such as Kokomo and Kokomo 2. In any case, there's many advanced methods for trying to get management understanding and interpretation of software. For the purpose of estimating. Here's an example of function point analysis, which weights the complexity of the software by inputs, outputs, interfaces, queries, files, calculates it. And then once this has been calculated, the total function points are converted to staff years, person years. So it's a formula for trying to arrive at how many people over what period of time by calculating software complexity using function points and then converting to staff years. So that's what function points are all about. So principles to walk away from here, when it comes to estimating, remember early estimates serve a purpose, even though they're more wrong than definitive estimates. If all estimates were definitive, it would take too long, probably. Learning curves rarely apply in project management, and software development is complicated, so there's more advanced methods used for this. What are some problems with cost estimation? Often projects are underestimated. You're going to have unexpected technical difficulties. That's kind of a given. Then you may have changes in specification, and many internal factors or external factors are going to occur. All right, so let's now take a look at our final topic today is alternative methods of developing a schedule. Next time we're together, we'll go into details of creating network diagrams, doing forward and backward paths in order to develop a schedule. But before we do that, this week I'm going to introduce you to some alternative methods of scheduling. Okay, one method that you will hear about is called CCPM, or Critical Chain Project Management, and that's based on theory of constraints. The idea behind theory of constraints is that no system can go faster than the slowest moving parts of the system. Another way of saying this, you may have heard this before, that a chain is only as strong as its weakest link. Something to that effect, that a system is governed by its constraints. And in critical chain project management, there are many constraints that Dr. Goldratt has observed that apply to projects that often we don't think about it until it's too late. And you'll understand this better when we actually create some schedules when we're together. Okay, so the idea is that critical chain does improve resource utilization. It's a cultural shift. It's a different way to think about approaching projects. So let's take a look at theory of constraints. What Goldratt says is you identify the constraint, exploit it, subordinate the system constraint, elevate it, and repeat it. Here's a diagram for this. Let me put it in simple terms. Find out what it is in the system that is slowing down your process. Expand that so your overall system speeds up. Once you do this, you'll identify other constraints or bottlenecks and then expand those. One of the reasons for a critical chain is the recognition that often it is resources that are constraints in a project. And so project managers should think about resources first as opposed to activities first. And then you should also consider using project buffers. We can look at this in more detail when we get here. This is a little too complicated. Let me just show you this. You'll see something in critical chain called feeder buffers, and you will see overall project buffers. And I'm just going to mention feeder buffers and project buffers briefly because critical chain says one mistake that project managers make is that when you identify how long an activity is going to take, you put a little extra time in that activity. And that extra time cascades throughout the entire project, and every activity has too much time allocated to it. What critical chain says is remove all extra time from every activity in your project and put that time at the very end at a buffer. And it should be understood that activities are going to take longer than planned, and that's fine so long as you don't consume your overall project buffer. That's the idea behind critical chain. One of the primary ideas is using project level buffers instead of time buffers for individual activities. All right, let's take a quick look at Agile project management. It's intended to be a new era in project management, and basically Agile is a reaction to the waterfall method. It's just called waterfall for complex system development because it looks like water cascading over a hill. You gather requirements, you design the system, you implement it, test it, deploy it, maintain it. From beginning to end, step by step, there's a sequence that happens. So one of the problems with this is imagine yourself in a waterfall system and you are halfway through the project and then there's major changes in the requirements. Now what do you do? Also imagine that you have multiple subsystems that you're developing and you're only integrating these subsystems at the very end of your project. If you do not bring them all together at once toward the end, then at that first time you bring all of your systems together, you're going to have something that's referred to as the Big Bang. Lots of problems happen at the very end. Okay, so there's two big problems with the waterfall method that has been identified. One of them, it's very static. Two, you get this Big Bang effect at the very end. Agile is recommending doing software at smaller pieces of time, focusing on functional software, where maybe you iteratively create smaller pieces and present it to the customer, get feedback. Therefore, it is not static, it's more fluid, and it's able to capture changes in requirements that happen along the way, and it avoids this final big bang. That's what the Agile method is designed to deal with. There's also something called the Scrum. Here's take a look at the Scrum process. You have iteration 1, 2, 3. You have sprints. This is special nomenclature in Agile project management. Let's take a look at some of the nomenclature. The sprint, the Scrum, the time box, the user stories, which is a way of capturing requirements, someone who leads the team. All right, so Agile intentionally has different nomenclature to capture the uniqueness of the method. But if I were going to take a look at the big picture and make a long story short, Agile is about breaking up larger systems into smaller pieces, focusing on smaller pieces at a time, also focusing on functional systems as opposed to waiting to the very end to do a thorough integration. These are all elements of Agile that's intended to make complex system development easier. In reality, though, it's all hard. Systems are getting more and more complex each day. This is a way of coping with it. It's still difficult, although some say that it is quite a bit of improvement over previous methods, such as the waterfall. Okay, back to critical chain. Let's take a look at some of the critiques of critical chain. Some say it's not really that much different from PERT, and when we're together, I'll show you why it's said that way. It's unproven at the portfolio level. Maybe you overestimate activities, cultural changes, unattainable. This is why, and I agree with this, I see some texts say one approach to trying to improve your project is to use critical chain. In my view, if you're not set up to handle some of these new methods, such as Agile or critical chain, you can't just try it once you have a history of doing your project another way. It's a major change effort that has to be implemented very thoughtfully and very carefully. Okay, let's discuss what we will do in the final lecture, and of course we will review all of this when we're together. Next lecture, we'll discuss soft skills. And over time, project management has progressed from what's known as the hard paradigm to the soft paradigm. What we've discussed to now has been fairly quantitative in nature. And at one time, that's all there was to project management, quantitative analysis, much of it coming from operations management background. But then it was recognized in complex system development, software development, project management, you need leadership, you need good communication skills, you need the ability to negotiate with others in your wider sphere of influence, and you need to influence people in a way that you may not have had to the same degree as a purely functional manager. So there's a big, important dimension of soft skills that we should consider: leadership, management, and human resources. We also must think about risk. We briefly discussed risk when we discussed the discount rate, but there's more to risk identification than just the financial element. In some sense, project management could be considered a risk management effort. If things just happen, if we define risk as anything that gets in the way of project success, just about anything could happen to prevent your project from being successful. If there were no risk, projects would just happen on their own, and you would not need project managers. So much of what a project manager does is, in essence, risk management. Then finally, we have scheduling. We will walk through next time the creation of a network diagram, and I will show you a couple of simple algorithms, the forward and backward pass. We will also compare and contrast the critical path method with the program evaluation and review technique method, so you understand how they're similar and how they're different. So those will be the next major elements that we consider during the next lecture. And of course, when we're together in Vietnam, we'll review this one more time, prepare for the final exam. I'll help you understand what the exam will and won't emphasize. And we'll get some practice together so that at the end of this course, you will walk out of it with a thorough understanding of project management, and you could start doing it on your own. Okay, as a reminder, think seriously about trying to remember the PMBOK framework. It will serve you well both in this course and I think in life in general, because it's a very structured, step-by-step approach for getting work done. And after all, isn't that what project management is about? A set of business processes for getting work done. And becoming a certified project manager and being able to exercise these processes is a mark of excellence in the workplace and will distinguish you from your competitors. So thanks for joining me, and we will see you again in a couple of weeks for Lecture 3.